Welcome, my dear children, to the part 1 of today's session from the chapter Waves. In this module, let us discuss about standing waves in strings and organ pipes. We have already seen that a standing wave or a stationary wave is a wave which is not moving. That is, it is at rest. When two waves with the same frequency, wavelength and amplitude traveling in opposite directions interfere, they produce a standing wave. You can see from the figure that two similar waves are approaching each other from opposite directions. These two will form a standing wave pattern. Now let us discuss about the conditions to have a standing wave. Two traveling waves can produce a standing wave if the waves are moving in opposite directions and they have the same amplitude and frequency. At certain instances, when the peaks of both the waves overlap, then the amplitude will add up to form the resultant wave. At certain instances, when the peak of one wave combine with the negative of the second wave, then the net amplitude becomes 0. In these two cases, standing waves are produced. In the case of a stationary wave, the waveform does not move. Now let us consider a wave, and suppose we have a rigid ball which do not move. When an incident wave hits the rigid ball, it gets reflected back with a phase difference of pi radians. Consider another wave which, when reflected and travels towards the left, and there is another incident wave which is coming towards the right. The incident wave is continuously coming from left to right, and the reflected wave will keep continuing from right to left. At some instant of time, there will be two waves, that is, one going towards the right and one going towards the left, and as a result of these, the two waves will overlap and form a standing wave. Now let us discuss the mathematical treatment of stationary waves. Let us take the wave traveling towards the left as y1 of xt is equivalent to a sine kx minus omega t, and the reflected wave to be yr of xt is equivalent to a sine kx plus omega t. According to the principle of superposition, the resultant wave will be y of xt is equivalent to yi of xt plus yr of xt. That is a sine kx minus omega t plus a sine kx plus omega t. Adding these two by the mathematical formula sin c plus sin d, we get y of xt is equivalent to 2a sin kx cos omega t. In the above equation, there is no variation in the amplitude or the part cos omega t for a particular instant of time. Therefore, it represents a standing wave pattern. As we can see from the above equation, the amplitude of the standing wave pattern will be 2a sin kx. That is, the amplitude is dependent on the position of the particle. Cos omega t represents the time dependent variation or the phase of the standing wave. Now let us see the difference between a traveling wave and a stationary wave. We know a traveling wave is also known as a progressive wave and a stationary wave is also known as a standing wave. In the case of a traveling wave, the waveform moves and movement of the waveform is always indicated by the movement of the peaks of the wave. In the case of stationary waves, the waveform does not move and also the peaks does not move. In the case of a traveling wave, the wave amplitude is same for all the elements in the medium, which is denoted by capital A. In the case of a stationary wave, the wave amplitude is different for different elements. Amplitude is denoted by A sin kx. In the case of a traveling wave, the amplitude is not dependent on the position of the elements of the medium, while in stationary wave, the amplitude is dependent on the position of the elements of the medium. In the case of a traveling wave, the displacement relation is given by y of xt is equivalent to a sin kx minus omega t plus phi, and in the case of a stationary wave, the amplitude is given by y of xt is equivalent to 2a sin kx into cos omega t. The representation of a traveling wave and a stationary wave is shown as the last point. Hope you might have got an idea about stationary waves in the case of a stretched string. Thank you, dear students.